what is an identity? An identity is whenever you end up with the same thing you started as. So there are certain operations that cause identities. For instance, if you have 4 and you want to add something to get to 4 again, you'd add 0. So you'd have 4. What about 3? What would you add to get to 3 again? 0. What about -7? What would you add to get to -7? 0. So in order to get the identity, you would use the additive inverse, which is 0. The additive inverse is always 0. But then if you're trying to get rid of a value that is being added, for instance, if 4 is being added, what would give you that 0? -4. If -2 is being added and you wanted to get rid of the -2, how would you get 0? +2. These are basically what we use to solve for equations. Use the additive inverse, which is 0, to figure out how do I get to 0 if something is being added or subtracted. Use the inverse operation. Likewise, we have the multiplicative inverse. Now, can you multiply something to get to 0? Yes, you'd also multiply 0. But the multiplicative inverse, we don't want our result to be 0. We want our result to be 1. The multiplicative inverse is 1. So, if you have something multiplying your x or your variable, we would want to use the multiplicative inverse rule, saying that anything times 1 is itself. That's the identity. So if anything times 1 is itself, then in order to get to 1, you would divide by itself. So if you had 4 times x, you would divide by 4 to get to 1x. If you had -2 times x, you would divide by -2 to get to that +1. Notice the difference between additive inverse and multiplicative inverse. With additive inverse, to get to that 0, you need to change the sign. But with multiplicative inverse, to get to that +1, you keep the sign. And then fractions. A lot of people hate fractions. I understand that. But that's just because you weren't taught in a way that makes them accessible. Fractions are just division problems waiting to happen. That's all they are. Fractions are just numerator divided by the denominator. And to remind you, numerator is on top, denominator is on bottom. That's all a fraction is numerator divided by denominator, except for you're not actually doing the division. You're just sitting it there and saying, one of these days we'll divide that. Fractions are more accurate answers, and best for slopes. We'll get to that later. To get rid of a fractional coefficient, there are two ways you can do it. You could divide by the fraction, or you can multiply by its reciprocal. What is a reciprocal? What a weird word. A reciprocal is the upside down of the fraction, or the flip. So for example, if I have 3/7, the reciprocal would be 7/3. So if I had 3/7x and I needed to get rid of this coefficient, let's say that's 3/7x is equal to 9, I can multiply both sides by the reciprocal, 7/3. If I have 3/7 times 7/3, remember multiplying fractions is multiplying straight across. 3 times 7 is 21. 7 times 3 is also 21. And anything divided by itself is multiplicative inverse, 1. So when I multiply 3/7 times 7/3, I get 1x. And then if I multiply 9 times 7/3, remember that 9 is just 9/1. 9 divided by 1 is still 9. But now I have a top and a bottom. Multiply the top. 9 times 7 is 63. Multiply the bottom. 1 times 3 is 3. And then simplify or divide. 63 divided by 3 is 21. So the answer to my question, 3/7 x equals 9, what is x? X would have to be 21. So that's how you deal with additive inverse is 0, multiplicative inverse is 1. Use inverse operations when you're adding or subtracting to get to 0, when you're multiplying or dividing to get to 1. And fractions, you don't have to worry, you just multiply by the reciprocal to get rid of that. If it's adding, you still have to add or subtract that fraction. But if it's multiplying by x, multiply by the reciprocal.